Greetings, good morning, good evening, good afternoon, whatever it is where you're at. Some kind of little update on this Delmonico that I've been working on. I'll show you something. Yes. The volume control now functions properly. Wasn't an easy job. However, I did not record video of this because I took this stuff to work and did it. But basically, I ordered some pots off Mouser, some audio taper type controls, 1 meg instead of 2. They were both 24 millimeters. So took the old pot apart, which was not easy. Almost damaged it. I didn't know how it'd come apart, but I knew it'd come apart. So yeah, I was able to get the pot apart, and I wish I'd have took a video of it, but like I said, it was a very hairy little operation. But needless to say, I managed to make it work, and it works fine.
Tonight, clear, low 33. Martin Luther King Jr. Day, sunny, high 59.
Join Mark Patrick seminars in South.
Yeah.
Your ability, weight gain, or your.
See, I don't even have an antenna hooked to it. But a couple of other things. I have the audio pot, the what they call the loudness control. It's fully repaired, functions great. Does exactly what I want to. The RF and IF alignment for the FM side was a little tougher. I tried several times to get a Bell response curve for this, and it would not perform like it should have. I wound up having to do. Sorry, I had to get something over here. But what I had to do is using the SCurves of mine. I had to go back and read up on this because I've never really done a lot of FM alignments on broadcast receivers. So I had to reread it and read a little theory on it. And then I watched a couple of videos and about other people doing it, and I realized what I was doing wrong. I was, hold that thought. All right, I'm back. Okay. I'm going to reference this book right here. This is The Theory and Servicing of AM, FM, and FM Stereo Receivers by Clarence R. Green and Robert M. Burke. It is very good information on how these things work and how to align them. So I'm going to pause you for a second, go find the section I'm looking for. And then we will bring you right back. Okay, I think it goes, I think I'll do this guerrilla style. Pardon me if I reach around it. I'm just going to kind of peruse this book together. One of the first things I want to show you is a block diagram. Is that too much light? Yes. That is too much light. That's better. Now, super heterodyne receivers for FM. This is a block diagram of how most of these, most radios, most radios that pick up FM broadcast are constructed. You have your antenna, you have your RF amplifier, you have your mixer. The mixer takes the input signal and mixes it with the local oscillator signal, creates an IF frequency called the intermediate frequency. So you have your station, your signal from the station comes in through the antenna, coupled to the RF amplifier, coupled to the mixer. It is mixed with a local oscillator frequency, which I believe is a higher frequency to give you a difference. In other words, this local oscillator, if I remember right, is 10.7 megahertz higher than the frequency that you're trying to tune for. Anyway, that will give you 10.7 megahertz IF through the IF amplifier. The IF signal is applied to the FM demodulator stage. And then an output of the demodulator stage comes down to the AFC, the automatic frequency control, and is then applied to the local oscillator, as you can see, to adjust it to get it back on frequency. And it uses the zero crossing of the FM demodulator to do that. And anyway, the output of the FM demodulator is applied to the audio amplifier and then to the speaker. That is the block diagram of how these things work. Now an AM FM receiver, kind of the same way, it's just a little bit more to it. You have your FM antenna right here through your FM RF amp applied to your converter or mixer, and then it goes down to the FM side IF cans, and then it goes into a second IF in the FM side of the can, and then it goes into a third FM IF amplifier, then applied to the demodulator. And of course you got your AFC signal. It goes back, it keeps the thing on frequency, automatic frequency control. You have your selector switch here for FM and AM. In this case, FM is selected, applied to the audio amp. Now, going back, here's on the AM mode. Signal comes in from your AM antenna, goes into your frequency converter, and it should be noted that when you select your band switch, you're turning on this converter or the FM converter. But anyway, your AM signal comes in. In this case, this would be the antenna right here, comes in to this tap on this tuning gang, and that tap right there is a variable tuning capacitor across this coil. So anyway, signal comes in through the converter, so it's mixed with a local signal, and the converter and the mixer is all together. Now, I mean, the oscillator and the mixers, what they actually call converters on AM. So it is mixed and converted, should I say, to an IF frequency, which is 455 kilohertz on most AM sets. So it goes to the other half of the first IF coil. Alright, goes through the second IF coil, goes into the AM demodulator. Then here you have a AM AVC, which is automatic volume control. So what happens there is, if you have a strong signal coming in, the AFC will reduce the gain of the IF stage to bring that down. So if you have a weak signal coming in, it reduces the gain of the IF stage to bring that signal up. And all that's trying to do is keep your output level constant. So it's not with varying signal. When the signal gets weak or it gets strong, due to propagation, or like it's fading in or fading out, it uses that circuit to try to keep that audio level at one level. Anyway, the output of the modulator goes to the AM part of the selector switch, then down to your audio amplifier. Simple as that. Okay. And I just turned the page here, and there's another section here. It's a little bit block diagram of an AM FM receiver that utilizes a different arrangement of the common stages. So in this case, it says here unswitched power supply to all stages. The other one, which I did not note, that's how they selected it, by turning power off to each particular stage. And on this radio, that is what they're doing. They're using the other one I just showed you. It's turning power off to the AM stage to select FM, and turning off the FM and turning on the AM to select AM. That's what this one does. But this is how this one works. you have your FM antenna and your RF amp, FM RF amp, and your converter / mixer. Then you have your AM RF amp. Anyway, if you're in FM mode, your signal comes right here, through your antenna, through your amplifier, through your converter, down to the selector switch. Then it selects which signal, the AM or the FM, is going to go through this pass stage. So here's your first FM IF right here, and then your AM converter. These two signals are running at the same time. Here's your FM, second FM IF and your first AM IF. And then it's applied to your third FM IF and then your second AM IF. And then your FM, it comes over to the converter, the detector, the FM detector. And then same thing as with your AM. AM comes here, it's converted. In other words, mixed, from the local oscillator that's inside this converter. So it's mixed. Applies it as an IF, intermediate frequency, comes to a second intermediate frequency, goes down to your AM detector, and through that same selector switch, like this one, this switch right here, and this switch right here are ganged together. So when you flip this switch, this one's going to do the same thing. Anyway, that's what tells it which one it wants to hear. And then, of course, with your AM detector here, goes back to your AGC. They call this AGC, automatic gain control, automatic volume control, does the same thing. Then it routes it to the IF stage and to the RF amp. So that's kind of how that works, and it's pretty good source material. So let's go on. And of course it explains about limiters, sharp cutoff pentode limiters, and all this kind of stuff, which I don't really want to get into that. I'm not teaching textbook. And then here it talks about this is how limiting action works on FM. We don't really want to get into that. Let me bring you back when I find the page I'm looking for. Alright, going a little further in the book here, this is talking about the discriminator of our radio. And this is what our this Delmonico uses, this system right here. It's called a Foster-Seeley discriminator, and I won't get into how all this stuff works because it's pretty long-haired stuff. But basically what happens is when there's a solid carrier with no frequency deviation, these two signals here from these rectifiers, in other words, that's a center tap transformer, and this is a you have center tap here. You have your RF through this coil right here. It's generating a signal, and the signal flow through these diodes both create voltages. These voltages, this is the output right here. When there's no change of voltage or no frequency deviation, this output is constant. As you change your frequencies, in other words, when you FM modulate, which means you're frequency modulating your FM carrier, which means your carrier is going lower and higher in frequency by 5 kilohertz. I'm sorry, 75 kilohertz for broadcast. As it shifts back and forth, it creates an imbalance in here because now because it's no longer in tune to 10.7, it has shifted frequency back and forth 75 kilohertz, and that shifting in frequency causes an imbalance in this circuit, which then creates an output, a varying output according to the imbalance of that. And that's it in its very simplistic form. So let's move on. And I'll have to probably correct myself just a little bit here. This is more accurate to what we are using in this radio right here. I'm not really correcting myself, but this is more akin to what we have. Your signal from your IF amp goes into the primary of the ratio detector coil right here. Then this is the ratio detector output. This is ground here. Comes through, and you have a coil here that eliminates any 10.7. I'm sorry. This coil, this is the center tap right here. It eliminates any 10.7 linkage that might be getting through there. And then the audio comes through this resistor to the audio output. And in this case, this is going to the function switch and also to the FM detector. And this is more like what we have right here. And this one here, this Foster Sealy, I was incorrect. This we don't. Hang on just a second. Now we're cooking with gas. Chinese pointer, always in the wrong place. Here is the discriminator section on our radio. Here's the final IF tube right here. This is the plate. Here's the primary. Same thing here. Here's the plate. Here's the primary. Same exact circuit. Here's the secondary. Look at there. There's a center tap. Let's get you a little closer. Look at there. Center tap. Comes down. Little coil. Through a resistor. To a little capacitor. Comes out. This is audio output. This goes over to the function switch. That's for mono FM or non-stereo FM. This goes down to the detector. I mean the multiplex. So look at there. See how the diode is right here? This diode is facing this way. This diode is facing this way. Look at that circuit. Now look at that circuit. Exactly the same. So this is what we have in our Delmonico receiver here. So the ratio detector is by far the most popular FM detector in FM receivers, and a basic circuit is shown in figure 1422. So there we go. Prominent features include a tertiary winding, LT, that has part of the transformer diodes connected in opposite polarity, and a large stabilizing capacitor, CR, which is this dude right here. We shall see that the circuit operation is similar in many respects to the discriminator. Hey, note, however, the output is taken from the tertiary winding. Tertiary, I finally got it right. Both the primary and secondary are tuned to the center frequency, FC, which is 10.7, as in the discriminator, and the same shifting in phase of the secondary voltage occurs as before. The primary voltage is applied to the secondary center tap by LT. So there's LT. Okay. Didn't know that. The tertiary winding, which consists of a few turns of wire coupled lightly to the low end of LP. LP, that's the primary right here. So right here. So I did not know that. We're learning this together. Since LT is tightly coupled to LP, no phase shift occurs from LP to LT. Tertiary voltage is in phase with the primary voltage. Thus, the voltage applied to the center of the secondary is in phase with the primary voltage, as in the discriminator. It is apparent then that the voltage is applied to the diodes in the same manner as in the discriminator, and the voltages vary with FM as before. That's modulated frequency. Thus, this aspect of the ratio detector needs no further explanation. Now, it gets on to talking about what happens, like right here, what happens when you're actually applying a modulated. But I think we've gotten ahead of ourselves here, but that's just kind of a rough idea of what's going on here. Now it starts talking about the SCurves of a ratio detector. And this is what we're interested in right here, this whole conversation. This is what I was able to achieve yesterday when I finally got a proper FM alignment. I used my SCurves SG80 to generate a sweep frequency, and I was able to obtain this curve. It's not a bell curve, it's an AM, because AM is you have a sharp, all you're doing is detecting a fluctuating AM voltage or AM signal. In FM, we're trying to detect something that's going higher and lower in frequency. So we need something that's capable of 75 kilohertz bandwidth right here. So we need bandwidth. This needs to be tuned flat, and I was able to achieve that yesterday. And my SG80 generates a 10.7 marker, so I knew where the center was. And what I simply did was adjust all the IF stages where I had equal amount of amplitude this way and equal amount of amplitude this way, and it was flat. So now when I tune a station in, it has room for the FM and the pilot and everything that's associated with FM can get through there. Then as I went to get the S-curve, in other words how the discriminator detects, I was able to put my marker, 10.7 marker, right in the middle. That's this crossing line right there. And once I'd done that, everything did perfect. So let me pause you again, see if we can find something different that I'm looking for. Be right back. Okay, this is what I was looking for. Sorry, I brought you on a rabbit chase, but this is kind of what I did on the FM alignment. Here is the response trace right here that I was looking for. Basically, you want this IF section to pass. This is the 3 dB points right here. That would be 10.6 and 10.8 megahertz. It's that's your 3 dB points. In other words, you use that 3 dB as a reference. So when I tune, you want this bell curve right here, or this curve, to be on the low side. You want that 3 dB point to be the exact same distance away that the high side would be. So in this case, this would be 100 kilohertz right here. This would be 100 kilohertz. 10.6 from 10.7 gives you 100 kilohertz. So that effective bandwidth is 200 kilohertz at the 3 dB points right here. Then here's 10.5, 10.9. I was able to achieve that yesterday. And I'm sorry, every time I talk I get this. This is the FM generator right here, the RF out. It's applied to the FM mixer, goes through the IF amps, it's applied to the detector circuitry. And this is kind of where it comes off. You'll notice this is our discriminator, part of the receiver. And your vertical end goes right here to the scope. Now this is not quite how I was doing it, but this is what you're looking for right here. You're looking for this response right here. When this response is tuned to this right here, this receiver now has the proper bandwidth to tune an FM signal. And that's exactly what we did. And then right here, this gives you the relationship. This is an FM signal. If you look at FM, you know, with a good scope, this is what it's going to look like. You see it varying. It's varying in frequency, and this is this audio right here, and it's giving you the swings right here. This is your mod in. Let's see, what is that right there? Horizontal in. Yeah, we ain't worry about that. This is 10.5. You notice the frequency is spread out, and as the frequency gets higher in frequency, you see it squeezes in together, and then as it goes back lower in frequency, it spreads out again. If you look at a scope and you vary frequency with an oscillator, you'll see the same thing. So here's what we had right here. The sweep marker generator had the RF, which is the signal out feeding the IF stage, the detector. And so let's go back here a minute. This is the RF right here, which is right there. That's the RF. Coming back down. There's the detector. Let me back up here. Detector. Then the vertical and horizontal, which is right here, which goes to my scope here and here. That's the test setup. The detector, depending on what you want to do, goes to either A or B. Okay, let's find A. Here's A. There's B. But what I did to get my trace is I just tied my probe, my detector probe, to B. I took this capacitor out because that's what they tell you to do in the alignment. This is that stabilizing cap. This in here was 10 microfarad non-polarized. Anyway, I just unhooked this cap, applied my detector probe here, and it was just the little isolated probe with a 27K resistor that went straight from through that 27K internal resistor from here to the sweep marker generator. That gave me my bell curve, and what I found out, one of the other things I found out is I was applying way too much signal, causing the receiver limiters to activate. When it does, it gives you a false reading. Once you got to have just enough signal to do what you have to do, no more. So anyway, once I learned that, figured that out, and I had my connection, finally got it in the right spot, because there's no way I could measure here without it loading the circuit down. I couldn't measure here, it loaded the circuit down. I wound up using this already. This is already a detector, so I didn't need anything else. This acted as the detector because that's what it did. Once I did that, I was able to get a proper bell curve. So coming back again, this is what you're looking at when you're trying to do an alignment. This is exactly what I was able to achieve. Matter of fact, right. This is what I was able to achieve right here. I had that flat. It was relatively flat right here, and I had the same distance between the 10 center frequency 10.7 as I did the lower part of the FM, the low side, and then the high side was equally spaced. And if you look at your scope when you're looking at your response, you can look at the graticals and see. And I just was able to spread mine out with the horizontal width control to get something that I could use. And then this book explains all kind of stuff right here. And this is what my S-curve looked like. You know, as your frequency is modulating high and low with your sweep, this detector responds accordingly. It goes high and low depending on what your sweep is. So there you go, 10.6, which represents the low part of the bell. Your 10.8, which represents the high spot. And you want that discriminator to swing voltage plus or minus in relationship to this bandwidth right here. Once you do that, get this and this right, that receiver will work perfect. And I guess that's all I want to go about that right there. We could go on for a long time, but I don't want to overdo it. But see if you can find this book right here. This book, if you can find it, will tell you everything. Will tell you everything that you need to know about this stuff. As a matter of fact, if anything I've learned from this, I haven't been in radio and TV since the 80s, or no, before that, late 70s, early 80s. That's how long it's been. And thought I knew everything, but apparently I forgot more than I remember, so I had to brush up on this. And this is one reason I'm working on this and working on this stuff right here, just to bring some of this stuff back. And once I've learned how to do this FM alignment properly, I've got another FM tube type radio that I aligned a long time ago, and I know it's not right. It never did work quite right, so I'm going to tackle that again. But anyway, getting back to this Delmonico, the volume control is fixed. I got the FM alignment fixed. I've got the dial accurate now. Got the AM alignment done, and it's accurate now. I replaced the dial cord on the tuner. Let's turn that around. I replaced the dial cord with new dial cord because the old dial cord was pretty worn out, and I couldn't get it to work right. So now I've got the proper tension on this. This is aligned to match up with the stations. So got all that done. The spring wound up. Remember, the spring was down here. I got that spring back up here where it belongs, out of the way. Somebody mentioned on one of my posts that that this thing's not strung right. So anyway, I got to thinking about that, and I said, yeah, you can't always believe what you see on these things when you get them, because you don't know who's messed with this thing over the years. This seems to work really good. One problem that I do have, and I'm not too worried about it, is the string wants to catch on top of each other, but it does. It's a little pop when you're tuning it, but it straightens out and it works fine. It doesn't affect anything. So anyway, I was able to get this tuned. Now the other problem that I had was, let's going back a minute, we're recapping all this stuff, is this is the FM detector stage right here. The problem that I had was I could not get proper recovered audio from this. In other words, if I selected FM stereo, it would go to crap. It would sound just horrible. And I started doing stage checks. I actually used, let's see if I can get you up here. This SG80 has ability to check your FM multiplex. So I was able to generate a multiplex signal with this analyzer and look at it going through the stages. Let's go back here a second. This is the detector stage right here. Remember, this is the output of the detector right here, which goes over to the FM, to just the regular FM stage here. This goes over there. Basically mono. I'm sorry, I think I'm lying to you. Nope, I'm not. It's just basically mono coming out. Sorry, I had to fix my sleeve. Anyway, here comes the signal. Comes out of the detector right here. Boom. Comes down, multiplex input. Okay? Alright, let's see. And here is the multiplex again. Coming here. Coming here. Coming over here to the 19 kilohertz amplifier. Anyway, I was able to check the signal through the stage, and I was able to determine that this stage was passing, this doubles. This is a frequency doubler right here. It takes that 19 kilohertz and creates 38 kilohertz. What this does is it applies the plus LR signals, and that's kind of my business, but trust me, it reinserts the stereo signal back into the multiplex signal. In other words, it strips it out and reassembles it. But anyway, could not get this stage to work properly. The separation was horrible. It did basically no separation. But I remember when I recapped this radio, there was one cap that I did not order, and it was set right there. That's the one cap that I did not change in this radio, and it sets right here. It's a 3 microfarad at 25 volts. I pulled that cap out, and it checked 251 picofarads. I think it was bad. I did not have a 3 at 25, so I found a 1. Put the 1 microfarad in there, applied power, and this thing came back to life. It worked like a dream. It had plenty of separation once I got the separation control. And this separation control, I have to tell you all about this radio. If you look at the circuit here, here's the separation right here. This is basically, and I think I showed this before, this separation control right here is on the cathodes of the on these two 17 EW8s, which basically is taking the left and right audio from the detector, from the multiplex detector, taking the left and right signals and basically just amplifying them and applying them to the function switch, which is giving you your stereo signal, which goes out to your output amplifiers. So your stereo signal from your detector goes through these two tubes. This separation control doesn't really affect how much of this left and how much of this right you're getting, or vice versa. What this actually does, at least that I could tell, is when you go from your FM to your FM stereo selection on your switch, if this is just not adjusted right, you will see a huge difference in your audio levels. So I adjusted this control to where when you're just on standard FM and you switch it back and forth, I adjusted this control to where it matched the standard FM signal level. So now when you switch it from standard FM to FM stereo, there's no change in the audio level, and that's how I adjusted that. So I got that taken care of. I actually measured a bunch of these components in here. A bunch of these resistors are out of tolerance, but it worked. Once I changed that capacitor, it worked. I'm not going to mess with it again unless I have to. Now I've got to go back and sum it up here. This pilot light is a little neon light. This pilot kind of threw me off at first. I said, why is this pilot on all the time? Well, it's not pilot as in FM pilot. It's actually the pilot light to tell you that your radio is on. But anyway, this bulb is bad. And if you remember, down here was the other one. This was the stereo indicator. That bulb was bad. I found another one to replace it, but it wasn't right. so I left it out. So I've got to order some of those. So really, that's all this receiver needs as far as that goes. Now, going back to this volume control real quick, I was able to replace the end guts, basically, if you will, the resistive elements inside this control. And I learned a lot about how to do that with this Japanese-made control. Of course, I couldn't. It's hard to find the exact stuff for this. You can look and look and look and look and look and spend more time than you think on this stuff. Anyway, I just changed the guts of it. I just changed the carbon elements inside it. And I had to do a little finagling, a little filing, this, that, and the other, and some stuff that, but it turned out nice. However, the tone control is a dual control as well, just like this one. This one is bad too. Yippers. And I believe the balance control appears to work. I think I don't have no problem with it. But the tone control is going to have to be repaired because the tone control is inoperative, and it's the same problem. Otherwise, I'll fix the tone control like I did the volume control, and let's see, what else am I supposed to do? Fix the tone control, change the neons out, and I think this thing will be ready to roll as far as the chassis is concerned. And then all I have to do then, sorry about that, all I have to do then is fix the case. It needs some attention, and I'm going to have to re-veneer it. And this shouldn't be a big deal. It's all flat, straight, curved, no weirdness to it. So I'll be able to just peel the old veneer off and get some that matches it, and order it, and put it on there, cut it to fit, and it'll be good to go. So this is where I stand on this. Sorry there wasn't a lot of probing and stuff like that. A little bit of theory, make your head burn. Yeah, let's turn me around and get some audio. So anyway, that's where I'm at on this. It's a little mini update, probably about 40 minutes long. But it plays fine. It detects fine on AM. It detects fine on FM. Yep. I even picked up a distant station in another town 40 miles away. So I'm good. The only other thing that I'm worried about, I'm going to turn power off. I'm going to show you this if we can see it. Let me turn and get away from me. The only other thing that I'm worried about, right here. A little too much light, huh? I don't know if you can see this well. But the sockets to the 50C5s are contaminated with all that grease residue from when it was in the kitchen. It's not good. I don't trust them. So it looks like I'm going to have to be doing some transplants. And you could tell, if you can see this, that stuff has gotten quite warm in here. I don't trust it. I don't like it. Much as I hate to, I'm probably going to find some more sockets to replace these two, so I'm going to wind up replacing those. I also have to change the safety cap. I had to add a safety cap in place of this old PCV ridden cap right here. This is on the line cord filter right here. I've got to change that. I haven't done it yet. So I need to do that. I need to change this capacitor with a safety cap. I need to replace these two tube sockets on the 50C5 and quite possibly this 12AX7 socket. And then the tone control. The balance seems to work. So but there's the new control, by the way, that I repaired. I just basically took the whole thing apart, changed the wafers right here with some 1 meg 24 millimeters. It took a little changing. The quite. I wouldn't recommend it if you just want to do it. If you hadn't done this kind of stuff before, don't do it. Let's see what else. About it. Up to date for now, and next time next time, hopefully next time we see this radio, all these extra things that I've done to it will be taken care of. So I need tone control, I need a safety cap for the line, I need to change the sockets on the tubes, the Alpha-250C5 and 12AX7 possibly. What else? Put some new neon bulbs in this thing. And that's it. Oh, and one more thing. Right here, I added a 100 picofarad cap across this 250 pike right here because I was getting a lot of 10.7 bleed through coming out into my multiplex and my recovered audio, and you could hear a little bit of a hiss. I added this right here, and that cleaned up that 10.7. I could look at it. I could look this line right here. This is the multiplex out from the detector, and you could see the 19 kilohertz pilot on there, which is fine. But it was just noisy, and I just added this cap here, and I may take it back off. It didn't really make that big a difference, but at the time, and there's that filter cap I was telling you about, the 10 microfarad non-polarized cap right there. That is the filter cap across the output of the discriminator. Anyway, that's it. Excuse me. That's it. Boring lecture. That's where I've been with this. I didn't record any of this stuff. Excuse me. So I'm done with that. It tuned up really good. So learn how to tune one. What I might do on the next one is duplicate, just put my test equipment back on and show you what a trace looks like. But I'm not going to touch the alignments because it's done. But I'll show you what the alignments, how I did it, and how I connected to this radio in the circuitry I connected it to, and what the response trace looks like, both the SCurve and the FMIF sweep. Anyway, y'all have a good day. Thanks for watching. All right, bye.